Hey everybody, let's go ahead and take a look at FRQ number 59 from the 2007 B of the BC AP exam. So it's a standard issue DiffEq, not much about it except for parts B, C, and D. Other than that, everything else is pretty easy. So they are going to ask us to do a little bit of Euler's method on this thing because it's a BC exam, but we can handle that. All we have to do is figure out how to find the new y, and then I think we're going to be okay. First question's pretty easy. They're going to ask us to find d squared y over dx squared. I think I'm going to do that over on this side because it doesn't take much space. So with A, it's dy over dx is equal to 3x plus 2y plus 1. Pretty straightforward. D squared y over dx squared. I won't waste your time with too much explanation. It'll be 3 plus 2 dy dx. And then 3 plus 2... And then since dy dx is already known, we can just go and punch in the 3x plus 2y plus 1. And you can leave it like that, or you can simplify it. It's up to you. We can go ahead and leave it like that for now. I don't know how useful it's going to be later on, but if we do need it, we can come back to it. What I really want to draw your attention to is Part B. Part B is arguably the hardest question in this DiffEq, and they're telling us to find the values of m, b, and r, for which this function right here is a solution to the differential equation. So remember, when we talk about something being a solution to a differential equation, what we're saying is we can plug in this value into y and get a dy dx out of it that makes sense. And so the way b works, now mind you, b is difficult on a couple of levels. One, because we're solving for 3 different variables, and there's no shortcuts here. We have to just solve by association, which is a technique we haven't used since we first started learning partial fractions, even before we were doing risky business on partial fractions. So we'll witness the return of that old friend. But the harder thing about B, and I'm going to warn you guys ahead of time now, is that I'm pretty sure there was an unintended answer for Part B, and that's where R changes a little bit. The letter R changes a little bit, and that is a perfectly valid solution, and I applaud the person who found it because I don't know if I would have seen that coming. Okay, but anyway, let's go ahead and take a look. It's safe to say that this guy, if I derive him, his derivative is y prime, or dy over dx, is equal to m plus r e to the rx. The derivative of e to the rx is itself times chain rule. The b goes away, so our first derivative here is going to be this. So I can go ahead and punch that into here. I can say m plus r e to the rx, right? And that's going to be equal to 3x plus 2, not y anymore, because y is actually a defined thing. It's this guy, right? And I've highlighted him in the wrong color here. You can't see that. It's this guy. So I can say 2, and then times mx plus b plus e to the rx power. And then a plus 1 on the outside. So from here, I'm going to go and just distribute like I normally do. And don't worry about the alternate answer just yet. We will talk about alternate quantum realities in a little bit. It actually reminds me of a really good episode of Star Trek: The Next Generation when Worf is going through alternate realities and they have to explain what's going on with them. So I'll talk about that too. E to the rx plus 1 here. And so I'm going to go and just solve this the traditional way. I'm going to go ahead and use solving by association, but before I do that, this shebang here on these last 3 terms, I'm going to go and rearrange them, and I'm going to do something with these x's. So I'm going to go and factor out an x from the first terms, so it'll be 3 plus 2m, and then it'll be plus 2e to the rx. I'm just going to switch the order of this thing, and then plus 2b plus 1. And that's all equal to m plus re to the rx. Now it's important to note that when we solve by association, we link up the x terms with the x terms, we link up the numbers to the numbers, the constants to the constants. So first important thing to note is that on the left side, there is no x term, which means this is 0x plus that. So when I go to solve by association, this guy will link in with this guy, making him really easy. So from here, 0 would equal 3 plus 2m, making m equal to negative 3 halves. Now, no matter what direction I go with the problem from here, this reality is never going to change. M will equal negative 3 halves under any situation. It's R that I need to pay attention to, and you'll see this in the rubric if you've already graded your FRQ. But I can safely say that M is done. He is equal to 3 halves, or negative 3 halves. I am going to now solve for the R term. Now that one actually is pretty straightforward, because from here, if I link up this 2e to the rx with this re to the rx, it's a pretty safe bet that 2 will be equal to r. Pretty simple, pretty straightforward right there. Now, all I have to do is link up the last things that didn't link up. So, what did I do? I had the x with the x, the e to the rx with the e to the rx, and now I just have to link up flat-out constant with flat-out constant. So I will say then that 2b plus 1 is equal to m, but we know that m is negative 3 halves. Again, how do we know? It's because we solved him a few seconds ago when we set 3 plus 2m equal to 0 when we linked up the x terms to solve by association. So from here, I'll go and just subtract 1 from either side. So that's going to get me 2b is equal to, looks like negative 5 over 2, which makes b ultimately negative 5 over 4. And those are your 3 answers right there. At this point, you can go and wrap it up, but I do want to entertain the possibility of the alternate answer. In the alternate version of this answer, and again, I applaud the person who came up with this, and I would have never seen it coming. But what they saw was they saw the original problem. They said that m plus re to the rx is equal to 3x plus 2mx. Did I forget a plus right here? I forgot a plus right there. Plus 2b. I'm going to scroll over a little bit here. Plus 2e to the rx plus 1. Now again, we understand that there is no change in reality for this guy. M will be equal to negative 3 halves. So in a way, you can look at him, you can look at this expression here as not m plus re to the rx. I'm going to delete you. But I can actually just move in that negative 3 halves into here. Now the alternate reality was to consider letting r equals 0. And again, it's one of those unintended consequences, and so, you know, this is just an alternate version of the answer, and in the episode of Star Trek The Next Generation, Mr. Data, he talks about how there's a theory in quantum physics that says that any situation that could have happened did happen in an alternate quantum reality. This is kind of like that episode right here. So we will go and just entertain the idea of letting r equal to 0. We've already taken care of this guy. This guy is actually already done. We know that the m, so we don't need to worry about him anymore. If I let r equal to 0, well, what I get is on the left side, I simply get negative 3 halves, because the r here will turn into 0, deleting this entire portion of the problem. And that's going to be equal to 2b plus 2e to the 0 times x plus 1. He's going to go away, and I get negative 3 halves equaling 2b plus 3. And then from here I subtract 3 from each side, so that'll be subtracting 6 over 2. And so negative 9 halves is equal to 2b, so b could have also equaled negative 9 fourths. And that would have worked out just the same. So how that person saw this coming, you know what, I applaud him. Didn't see it coming. But yeah, give credit where credit is due. I will take either one of these answers, not that I'm grading this thing, but the AP exam would take any one of these answers. I'll be honest with you, the more obvious one was the initial version of B, where you just solve by association. Let me clean up the board real quick. I'll be back in a flash with letters C and D for some Euler's method. Alright, now that we're back, let's talk Euler's method. It says let y equals f of x be the particular solution with a differential equation with f of 0 equaling -2. Use Euler's method starting at x equals 0 with a step size of 1/2 to approximate f of 1. Show your work that leads to the answer. We haven't done this in a long time, but I'm going to go ahead and make our good old buddy the table for Euler's method. Now, if you don't remember what goes into the table, don't worry. It's okay. We will figure it out. I know that x is going to go here, y will go here, dy over dx is going to go here, and we know that new y will go here. Now, before we begin, what the heck is new y? Well, remember, new y was always equal to m, which is the slope at that moment in time, or dy dx, times delta x plus old y. And that's how we get our new y. And so from here, I'm going to go ahead and just link this thing in. So I know that f of 0 equals -2. Let's find out what dy dx is at that moment in time. If I plug him into the original dy dx, I should get -3. And then to find new y, I'm going to go ahead and do dy dx, or m, which is -3, times delta x. Well, delta x, and I probably should have done this from the beginning. Since I'm using a step size of 1/2, my next step is going to be 0.5 and then 1. So ultimately, it's a two-step Euler's method. So my delta x is going to be 0.5. And then I'm going to add the old y to it, so plus -2. Now, in case you guys are wondering, yes, I did do this before, and that is how I'm able to get this number so quickly. -7/2. So that's going to go into here. And now I go and just find dy dx again. Again, I take these numbers, I plug them into the dy dx. I will end up with -9/2. To get the new y, it's going to be m, which is dy dx, -9/2 times delta x, which is going to be 1/2, or 0.5, plus the old y. Well, the old y was -7/2. And then after all this mumbo-jumbo is done, you end up getting -23/4. Please be careful. You are actually done when you find out what that is. Don't go any further, please. F of 1 is approximately equal to -23/4. And you're done. Okay, let's take a look at D. Another Euler's method problem. Now this one here is a little more complicated. It's I would say it's probably ranked number 2 for the hardest problem on this Diffie Q here. It says that y equals g of x be another solution to the differential equation with the initial condition g of 0 equals k. Well, that's going to be important. Where k is a constant, using Euler's method starting at 0 with a step size of 1, gives the approximation g of 1 is approximately 0. Find the value of k. So we haven't really had to apply Euler's method this way before, but I think the intuition should be pretty good for you guys. Again, I'm going to draw the table. And so I'm going to say x, y, dy, dx, and then new y. Well, I'm going to start off with 0. I will end at 1. So what was my y at that moment in time? My y was k. And then dy dx, now this was the hardest part for me because I wasn't sure what differential equation they were talking about. I don't know why, I just wasn't reading it correctly. But it's this one. This is the differential equation that they are talking about here. So when I want to find the slope, I'm going to go ahead and just plug in 0 and y into these things. And so I should end up with 0 plus 2k plus 1. And then in order to get new y, I'm going to take dy dx. So it's going to be 2k plus 1. That's going to be multiplied by delta x, which is 1. And then plus old y, which is k. Now, why is this new y so important? Well, because that's what goes into here. And I know that the 2k plus 1 plus k will be equal to 0. They told me that in the problem. I know that that's what this is supposed to become. So I'm going to go and solve for k now. So 3k plus 1 equals 0. So k should equal -1/3. And we are done. Great job. Thanks for listening, guys. I will see you guys in the next FRQ. Feel free to post comments or questions in the comments section. I would love to know what you guys think. See ya.